Hello everyone, and welcome you all to this class. This is mathematics class, and today we'll be solving the second example on this application of differentiation we looked at in our previous class. In particular, we looked at the absolute minimum and the maximum value of a function. So let's look at this second example. The absolute maximum of the function y is equals to x squared minus x plus 1 on 0, 2 is. So before you find the absolute maximum value or absolute minimum value of a function on a particular interval, you need to find the critical points of that very function. So we know that at the critical point, the first derivative of the function with respect to the independent variable is equal to what? 0. So we are going to differentiate this function with respect to the independent variable x as we have it here. So if you differentiate x squared, you are going to have what? 2x, right? By simply bringing down the power and subtracting 1 from the power. Then if you differentiate x, you are going to have if you differentiate minus x, you are going to have minus 1. Then if you differentiate 1, you are going to get what? 0. So, and this first derivative should be equated to what? 0 at the critical point. So this will be equal to 0, right? So if you solve this, this implies that 2x is what? 1. This implies that what? 2x is 1 by moving negative 1 to the other side. And if you divide both sides by 2, it implies that x is what? Half. So we got x being half as the critical point. What I just wrote down here is that we need to substitute x for half. We got the critical point half. So after getting the critical point, you substitute the critical points. So if the critical points are 2, you substitute them. If the critical point is 1, you substitute. If the critical points are 3, you substitute. You substitute all of them. Then after substituting the critical points, you also substitute the endpoints of the interval. The endpoints of this interval is 0 and 2. So the critical point I got is half. So I will substitute x for half and also x for the endpoint 0 and 2. So when x is half, when x equals half, y will be equal to, let's check if x is half, put half here. We are going to have what? Half raised to power 2 minus half plus 1. I'm putting x for half here. Then half raised to power 2 is 1 over 4 minus half plus 1. So if you simplify this fraction, you are going to get what? 3 over what? 4 as your answer. So you are going to put x for when x equal to 0. When x is 0, y will be equal to, if x is 0, if you put 0 here, you are going to get 0. If you put 0 here, you are going to get 0. What is now remaining for the value of y is 1. So when x is 0, y will be 1. When x equals 2. So let's check. When x is 2, let's check what will be the value of y. We are going to put x for 2 here. So we are going to have 2 raised to power 2 minus 2 plus 1. We put x for 2 here. So 2 raised to power 2 is 4 minus 2 plus 1. And 4 minus 2 is 2 plus 1, you have 3. So from what we got, we noticed that 3 is the biggest. If you compare 3 and 3 over 4 and 1, 3 is the biggest. So 3 is now the absolute maximum value of this function on this very interval. So thank you for being part of this class. I'm expecting an upcoming class. Bye.